Good morning, ladies and gentlemen. Thank you for sharing your responses on the Bellwork. Let's go ahead and take a look at the difference between explicit versus recursive formulas for for sequences. And we've got a couple different kinds here. So if we look at this first kind, it appears as though our terms are decreasing by 2.1 in value each successive term that we move over from left to right. And so it looks to me like an arithmetic sequence. The explicit formula starting off with a sub 1, 11.4, and then down by, there's my minus my constant difference, 2.1, and then times my input, n minus 1. Raise your hand if you have the explicit formula correct for number 1. Explicit's correct. Nice job. The recursive, right, the recursive formula, you need two things. You need a starting value, and then you need a rule based on the previous term that will be used to give you the current term. And so it looks to me like we can look at the previous term and subtract 2.1 from it, and that'll give us our current term a sub n's value. Nice job. And then lastly, a sub 10, we could extend the pattern down by 2.1 every term all the way until the 10th term. Raise your hand if you have negative 7.5 for the 10th term. Way to go, you guys. Great work. What questions do you have about number 1? Unlike the arithmetic sequence in number 1, number 2 has a distinctly different pattern. What kind of sequence, right, do we see in the second one? What kind of sequence is that? Sydney?
Geometric.
Geometric. And thank you. And instead of having a constant difference between successive terms, it appears we have a constant multiplier. And that multiplier we'll call R, right, the ratio between successive terms. That'll show up in our series activity today. That ratio R is negative 1/2. Look at that alternating sign. That's pretty sweet. So it looks like my start value, G sub 1 is 880 times, and then my constant ratio R, negative 1/2 to the, and there's my input, n minus 1. Recursively, I need my start value, and then I need a rule that gives me the current term based on the previous term's value. It looks like I times by negative 1/2 every time. Nice work. And if we did that out, we get about negative 1.79. Raise your hand if you have G sub 10. G sub 10. Great work, you guys. What questions do you have on the first two? Okay, and so while we had arithmetic, we had geometric. Let's take a look at this one. And again, my terms, they look like, they all have that 3 in them, my start value, but then it looks like we're take my input, plug it in, there's that negative 1/2 again. Yes, negative 1/2. So 3 to negative 3/2 is negative 1/2. And then times negative 1/2 again is going to be 3/4. Nice job. Awesome. And so it looks to me like if we take, there, if we scoot that, now do I have our recursive definition? So the current term is given by the previous multiplied by negative 1/2. Good job. My explicit formula gives me the nth term simply by plugging in. So we can check and see if this works out. So if we were to plug in 3 for my subscript n, that would give me my third term. Let's try it. So I put in 3 in for n, minus 1 is 2. Negative 2 squared is positive 4, and I get 3/4. Excellent. All right, so here's my explicit formula. Applying my rule, or plugging into the explicit formula when n equals 10 for the 10th term value, we get negative 0.006. Raise your hand if you got that. Did anybody get that for the 10th term? Yes? So let's try. Let's plug in 10 here, and we can use our calculator. So if we did 10 minus 1 is the 9th, right, is the 9th. And so then I take 3 over, parentheses, negative 2, close parentheses, so the 9th. Yeah, so if we just rounded that up, right, negative 0.005859 then that would give us about 0.006. Awesome. What questions do you guys have about your Bellwork today? Great. So let's go ahead and take a look at our OTL number B. So today is going to be our last quasi letter number labeled OTL. When you have OTLC, after that we're going to be going with OTL number 1, 2, 3, etc. At this time I ask that you go ahead and make sure that your heading is complete, name first and last, 1A, And number B, give yourself credit for those you completed out of 12, please. Divide, enter, multiply by 4. Remember, we're rounding to the nearest tenth of a point, and our OTLs are out of 4 this year to account for our homework being 15% weighted there. So make sure you're rounding to the nearest tenth of a point. Questions about the OTL scoring? And then pass them back to front, please. Thank you, front rowers, for making sure they're facing the same direction. I appreciate your help. Very good. Thank you for your help. So what's going on today? Today we're going to build on our sequences from last class and see how series are connected to the idea of sequences. In fact, we'll revisit that concept and connection during our closure today. But first, we've got our activity. We've got stamped eligible items on 3B, 6C, 8, 10B, and 14B. If you want to go ahead and take a minute and put a quick circle on the stamped eligible items. The recent addition of Brendan to our class has made 3 even groups of 4. This is great. I can't wait to get started on this activity. I am going to turn off the smartboard to save energy during the activity, but then we'll revisit it when we get to closure. So at this time, I'll go ahead and pause the recording. And if you guys would scoot into your cooperative learning groups and get started, that'd be awesome. Thank you, ladies and gentlemen. Let's go ahead and take a look at our closure for the day. So we've got a big idea here. We're building on our notion of sequences now and introducing series. And so for our first closure item, I'd like you to write down how are series and sequences related. Please be ready to share your written response. For number 2 and number 3, I've asked you to generalize the formula for the nth partial sum of an arithmetic sequence first for number 2, and then a geometric sequence for number 3. And these are the big ideas that I wanted you to take away from today's activity. So how are series and sequences related, right? How are they related? Riley?
Series are the sum of the numbers in a sequence.
Absolutely, right? When we find series is the sum of the terms in a sequence. So, series, bless you, is the sum of the terms in a sequence. Nice job. Thank you, Riley. The sum of the first n terms in an arithmetic sequence with first term a sub 1 and constant difference g is given by. So what's the sum of those first n terms, right? Generalized. Sophia?
N.
What's my formula for the sum of arithmetic? Yeah, perfect. Oh, you're saying n. Gotcha.
Sorry. N times a1 plus a to the n, a sub n divided by 2.
Awesome. Raise your hand if you have the same thing as Sophia. Yes. And let's do the same for geometric this time. Go gadget arm. This is totally going to work out. And so what's our formula then for our geometric series partial sum? Courtney?
G sub 1 is 1 minus r to the n all over 1 minus r.
Awesome. And raise your hand if you have the same. 1 minus r. Yes, way to go, you guys. That's perfect. Okay, so we got OTL number C with our last quasi-numbered lettered alpha OTL listing. We're going to finish the series activity, including stamps on 14B and 16. That's part of your assignment. Then we've got a short assignment. 8 problems from page 449 and 4 problems from 478. Again, I'm trying to keep the OTLs manageable, right? And you just get at the main ideas for a grand total of 12. Nice job today. I'm going to post the recording on our Moodle site.